Everyone, this is Mr. Younger, and I'm going to lead us through synthetic division. We're going to start off with an opener here where I'm going to actually have you complete long division based on this problem here. So basically, you're going to use long division to see if x plus 3 is a factor of x cubed minus 2x squared minus 9x plus 18. If you don't know what long division is, I'm going to actually have you go back a lesson and watch the video on Unit 6, Lesson 7, as that's a good introduction into what we're doing today. So go ahead and hit pause, work through that long division problem unless you're already done with it. And then once you press play, I'll have your answer for you. All right, so here's your long division. And what you should have found is that you get a remainder of 0. And your quotient, which is the result of the division problem, is x squared minus 5x plus 6. All right, so we're going to talk about what this means and what just happened by getting a remainder of 0. But I want to tie this process into what we're covering today, which is called synthetic division. Okay, so long division, again, if this is new to you, if you're not sure, go back and watch the video on Unit 6, Lesson 7. That one covers how to do long division. So synthetic division, it's going to accomplish the same process as what long division does, but it's a much quicker, much more simple way. So a couple things before we jump into that synthetic division. What we're doing, and long division does this, but synthetic division kind of takes this a step further in that we're checking to see, is x plus 3 a factor? So when something is written like that with an x, right, and no equal sign, it's called an expression. So this expression, we're checking to see, is it a factor? Okay, by getting a remainder of 0, we already know that it is. We're going to pretend that this didn't happen yet. Okay, so what we also need to figure out with synthetic division is if we set that factor equal to 0, what do we get? We get -3. Remember, we factor so that we can set them equal to 0 and find their solutions. So by doing x equals -3, we're checking, is that a solution? I'm putting it in quotations because we haven't confirmed it yet. You might also hear this referred to as a 0. Okay, so with synthetic division, we're doing both of these things. We're checking, is x plus 3 a factor? And thus, is -3 a solution? All right, so this work always needs to happen where we figure out what the possible solution is. The reason that needs to happen is because when we do our synthetic division, you're going to make a little half box here. And we're going to put what we think is the solution, which is -3, in that half box. I'm going to refer to this half box as the chair. So what we think is the solution will always go into the chair. And now what's nice about synthetic division is we don't need all of these x cubes, x squareds, and x's. We're going to bring in all of the coefficients, which are numbers in front of all these x's. So 1, -2, -9, and 18. And now we're ready to roll. Okay, so this is your entire setup. One thing that's great about it, that's different from long division, that this is an addition bar as opposed to subtraction. So our room to make error is minimized here. First thing we're going to always do is you bring down this first number, you don't change it. It comes below our addition bar and we move on. Then once we get a number below this addition bar, we will take that number and multiply it by the number in the chair. So I'm going to multiply it by -3. So 1 times -3 is -3. -2 plus -3 is -5. Okay, so we'll always take the number below, multiply it by the number in the chair, and then add down. -2 minus 3 is -5. And then the process starts over again. So I'm going to multiply -5 by the number in the chair, which is -3 still. That gives me a positive 15. -9 plus positive 15 is 6. And we're going to do this one last time. Times -3 to get -18, which gives us a remainder of 0, which we should expect. This is the same remainder that we got from doing long division. And in fact, do we notice in our long division where this 1, -5, and 6 might be? How about up here in our quotient? That 1 corresponds to this 1 in front of the x squared. This -5 corresponds to -5 in front of the x here. This 6 corresponds to this 6. That is just a constant from our quotient from the long division. So we have accomplished the same thing over here. And look how much shorter and easier it is compared to long division. Okay, so here's what we have just done. By finding a remainder of 0, one thing that we want to always write down is, what do these numbers represent? So I always put a little dashed line separating the last number, which is that remainder, from the rest of the equation. The rest of the equation, we're going to always interpret it by moving right to left. And the reason that is because this is our constant. It'll always be the constant. This is our linear. It'll always be the linear, okay, which is like our x term. This is our quadratic. It'll always be your quadratic. So if we work right to left, it's just always like a constant and then x squared and then x cubed, and x to the fourth, etc. So just make sure we get all those terms lined up correctly. Okay, so this equation really comes out to be 1x squared minus 5x plus 6, and we don't need the remainder. Now, here's why this is useful and what we really just accomplished. We took the original equation of x cubed minus 2x squared minus 9x plus 18, and it's equal to what we divided by, x plus 3, which is a factor because we got a remainder of 0, times our quotient, which is x squared minus 5x plus 6. And guess what? We could continue to factor this, okay? And that's all division is. It's another tool to help us factor. If we can't use our factor box, or if we can't use grouping, we need another tool. That's where synthetic division and long division come in. So this is what we accomplished. We also proved that -3 is a solution, and we can find our last two solutions from this quadratic. So in total, or the difference between the two, because the question I got in class is, why do we even need long division if we can just do synthetic division every time? Synthetic division only works if we are dividing by a linear term, which we are here, right? X plus 3 is linear. If it's not linear, if it's something like x squared, that's where we need long division. So synthetic division only works select amount of times. All right. So down here, in order to use synthetic division, you must take the coefficients. Coefficients being the numbers in front of variables. And just like with long division, watch out for polynomial functions that skip terms, right? If we are dealing with an x cubed, and let's pretend we didn't have x squared there, we would need to add in 0x. We don't have that here, but we'll get to an example that does have that. All right, well, let's go through. We're going to do 3 examples together. They'll go quick. We'll kind of remind ourselves as to what we're doing here. So this is asking, use synthetic division for the following. Basically, we're trying to see x plus 3, which would be a factor. So we're checking, is it a factor? And if it is a factor, that would imply that -3 is a solution. So we're checking both of these. And basically our answer to both of them depends on our remainder. So -3 in the chair. 1, -2, 1, -6. So all those coefficients, right? 1, -2, 1, -6. This is an addition line. We'll bring down that 1. And we'll take 1 times the number in the chair. 1 times -3 is -3. -2 minus 3 is -5. -5 times -3 is 15. 15 plus 1 is 16. 16 times -3 is -48. -6 minus 48 is -54, which is our remainder. So in this case, since we got a remainder that is not 0, this is not a factor, and thus it is not a solution. We can still write our result here. So what this equation represents, by identifying what these numbers represent, okay, are constant, linear, and quadratic terms. And so really what this equation would look like is x squared minus 5x plus 16. And then if we have a remainder, right, think about if you have a remainder when you divide, like, right, if you do 10 divided by 3, it doesn't work out to be a whole number, but we get a decimal. We can get like a decimal equivalent in an equation. And what that looks like is if we add on the remainder, -54, and we divide it by what we were originally dividing by, which is x plus 3. Okay, so this portion here signals to us that there is a remainder, and thus this is not a factor, or x plus 3 is not a factor of our original polynomial. Right, so that one, basically, if it's not a factor or solution, we don't care about it. We want them to be factors. We want them to be solutions. All right, let's go ahead and do this next one, where we're going to figure out, is n minus 2 a factor? At the same time, we're going to also see, is 2 a solution? So in this case, 2 goes in our chair. Then our coefficients are 1, 1, -5. But notice there's no linear term here, right? It goes 4, 3, 2, but no linear, no just n. So I need that 0 to serve as a placeholder. Without that 0, you're going to get it wrong. So bring down the 1, and the process starts. 1 times 2 is 2. 1 plus 2 is 3. 3 times 2 is 6. -5 plus 6 is 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. -4 plus 4 is 0, which is great. That's what we wanted to have happen. Okay, so we get a remainder of 0. Let's state what all these terms represent. It's our constant, our linear, our quadratic, and our cubic. And so what we have just done is we took the original equation of n to the 4th plus n cubed minus 5n squared minus 4, and we have factored it to what we divided by, n minus 2, times our quotient here, the result of us doing that synthetic division, which is n cubed plus 3n squared plus n plus 2. These are equal, okay, our original equation, and it's factored or partially factored form, right? This would still need to be factored a little bit further. All right, well, we've got 2 down. We're gonna do one more, as there is one little difference for what we're gonna do on this last part. So page 19 now, last problem. And what you're gonna notice is, if we're trying to figure out if 2x minus 3 is a factor, let's figure out what that solution would be. So I'm gonna set 2x minus 3 equal to 0. I get 2x equals 3. So x equals 3/2. So we're working with a fraction. It's going to be a little bit tougher, and I'm going to encourage us to try to do this without the use of a calculator. So 3/2 goes in our chair. That doesn't change. Our coefficients, we'll write them down right next to it. That doesn't change. 2, 5, -2, -15. Now we're on our way. So I bring down the 2, that does not change. So now when I do 2 times 3/2, how we multiply fractions is you multiply the numerators or the tops together and the denominators together. And remember, if 2 is not a fraction, I can put it over 1 without changing it, right? 2 divided by 1 is still 2. And now I have 2 numerators that can be multiplied. 2 times 3 is 6. And 2 denominators that can be multiplied, which is 2. Giving us 6 divided by 2, which is 3. Okay, so remember, all division or all fractions are just division problems. So how can I get 3 without having to show any work? Really, what we're doing is we are multiplying by the top number, right? 2 times 3, that's how we got 6. And then dividing by the bottom number. So 2 times 3 is 6, divided by 2 is 3. 5 plus 3 is 8, and we're going to start all over. 8 times 3 is 24, divided by 2 is 12. -2 plus 12 is 10. 10 times 3 is 30. 30 divided by 2 is 15, giving us a remainder of 0, which is great. Now here's the problem. When we go to say what our factored form is, 2x cubed plus 5x squared minus 2x minus 15, it equals 2x minus 3, but these numbers aren't the coefficients for what we would take 2x minus 3 by to get it to equal 2x cubed plus 5x squared minus 2x minus 15. So what we need to do, there's 2 ways to approach this. You can ask yourself, what's the greatest common factor of 2, 8, and 10? You would all tell me 2. That same 2 just shows up in our chair for what we're dividing by, right? I'm dividing by 2 in my chair. So whatever number I'm dividing by in my chair is the number I'm going to divide all these coefficients by at the very end. So this is really a 1. really a 4, and really a 5, making our final equation x squared plus 4x plus 5. And now these are equal. And what we've done is stated that 2x minus 3 is a factor, and thus 3 halves, or x equals 3 halves, is a solution. All right. Well, thanks for watching. Make sure you complete your homework for this lesson. And that is it for today. Have a great rest of your day.